All right, hello students. Now we're moving on with problem number 2. It says plot and connect the points E, F, G, and G. It says then give the best name for the polygon and determine the area. Well, you don't have this underneath problem 2. This picture is actually back from problem 1, kind of what we did in problem 1. It's okay to use that same grid, so you can kind of just flip the page back and forth and fill out the grid. Actually, you could probably even just turn back over to problem 1 with the grid and kind of go off of my screen as we plot points, and then of course as we start and go back as we start solving. So once again, you don't have this grid there. I don't expect you to draw this. I expect you to flip back to problem 1 and use the grid we used for the last one. All right, so let's go ahead and now plot these points for E, F, and G. So E is at -8, 8. So 1, 2, 3, 4, 5, 6, 7, 8, and then up 8, 1, 2, 3, 4, 5, 6, 7, 8. And as you can see, we're kind of going into the other quadrant, in the quadrant 2. This is one reason why it makes it okay that we use the grid from problem 1. F is -2, 5. So 1, 2, up 5, 1, 2, 3, 4, and 5. And then, of course, we're going to connect the dots. Oops, that's not very straight, but that's okay. It'll take care of what we need. And the last one, G is -7, 2. So 1, 2, 3, 4, 5, 6, 7. So I counted 7 in a negative direction and go up 2, which is a positive. Upward is a positive direction. And of course, this is G. All right, so if we look at this, first let's go and identify the shape. Just like the other one, this is just a triangle. This is not a right triangle. As you can see, there are no given right angles. So this is just simply a triangle. I don't know what's going on. There it is. All right. So that is a triangle. Now we have to determine the area. Well, there is no given right angle anywhere. Remember, to determine the area of a triangle, we need a right angle, either going from one peak straight down here. We can make that a right angle, but then we couldn't determine the distances of any of the lines. And that's what we need. We need a right angle. Well, if we look at this, we could actually draw, I guess, kind of like a box around it and create a rectangle or a square, depending on the dimensions, and figure out the area of the entire square or rectangle and then subtract the pieces that aren't there. So let's go ahead and do that. So if you have a different color, let's go ahead and pull that out. I'm going to pull out my red. So if we go from this point, we draw a line all the way down here to this point. We're going from E pretty much equal to point F, and draw that line through, I'm sorry, point G, excuse me. Then draw a line through G all the way to F, or equal to F, then draw it through F, equal to E, and then draw it all the way across here. We now have I believe this is a square if we count correctly. There's 1, 2, 3, 4, 5, 6. This has the units of 6. Going up, we have 1, 2, 3, 4, 5, 6. This also has 6 units. And now we have a square. So what we can do here is first determine the area of, oops, I didn't mean to do that. Go ahead and put that back in there. Let's go ahead and first determine the area of the square. Well, to find the area of a square is just simply side times side. So 6 times 6 is 36. And of course, we're talking about units squared. But now we have like 3 triangles here that are not part of the triangle that we're interested in. Remember, we're interested in this blue triangle here. So we want to keep this area, but we want to get rid of the red triangle areas. We want to get rid of this one. We want to get rid of this one. And we want to get rid of this one. Now the question is, can we do that? The answer is absolutely, we can. If we look at this actually we'll start with this top one right here. So we'll call this triangle 1. We'll call this T1. Let's go ahead and label it. Let's go ahead and pull out the green and call this T1 up here. If I look at this, remember this has a side of 6 because this is a square, or a height because here is a right angle right here. And then it has a base of 1, 2, 3 because remember, we want to stop right here. So this has a height of 6 and a base of 3. So we go back to the area of a triangle, which is 1/2 times the base, which is 3, times the height, which is 6. And we go ahead and do the multiplication. Well, you have a calculator, but if we did the multiplication, half of 6 is 3. 3 times 3 is 9. So this would be 9 units squared. So this T1 right here has a height of 6 and a base of 3. And then, of course, here's the right angle. So this creates a red kind of right triangle. And, of course, we can kind of work our way around and do the same thing for this one. Here's our right angle. So once again, this has a base down here of 1, 2, 3. So this has a base of 3. This has a height now of 1, 2, 3, 4. We're going to stop right here at the dot, so that'd be 5. So now this one has a base of 3, and a height of 5. So let's go ahead and come down here. Oops. Let's go ahead and pull it down. So now we have triangle T2. I didn't label it. Let's go ahead and pull up my pen and label it real quick. So this triangle over here is T2. Notice I'm just writing it pretty close to it, just to help kind of organize what we're doing. So we have 1/2 times, well, the base once again is 3. The height is 5. So what does that equal? Well, 5 times 3 is 15. Half of 15 is 7.5. Once again, if you have the calculator, you can use it perfectly fine. I'm just using my math skills, knowing that this is 15 and half of 15 is 7.5. All right, so now we have one more. We have just simply this right triangle over here. We'll call that T3. And let's go ahead and go through the numbers. Well, first we have, remember, it stops right here at this dot. So this would be a unit of 1, a base of 1. And of course, it goes all the way to the top here of E. So of course, that's 6 because remember, all these sides are 6. All right, so T3 would be 1/2, or let's go ahead and put that in there. T3 is equal to 1/2 times the base of 1 times the height of 6, which would be equal to, well, half of 6 is 3. 3 times 1 is 3. And of course, we're talking about units squared. Oops. Yeah, that was right. All right. So now all we really want is the area of this blue triangle. So let's go ahead. I'm going to put blue triangle for mine because I labeled it blue. Now, how do we determine that? Well, if I take the entire square right here, and I subtract the red pieces that are not part of the blue triangle, that would give us the area of the blue triangle. So the square is 36 units squared. I want to subtract out T1. T1, of course, is 9 units. So I'll just put 9. Notice I'm just leaving off the units squared just to kind of keep this clean. I'm going to subtract T2, this red T2 right here, which is 7.5. Oops, I forgot to put the subtraction sign. Make sure I put the subtraction sign in. And the last one is T3 over here, or triangle 3, which of course is 3. Now I can go ahead, I can use the calculator to do the work for us if we need it. But 36 minus 9 minus 7.5 minus 3, plug it into the calculator. Go and take a moment and do that. And hopefully you get 16.5. And of course, we're talking about units squared. So even though the figure did not give us a right triangle, something that we know, or any kind of right angle, we still can use some math skills to determine it. We know how to find the area of a square or rectangle. So I subtract the pieces that aren't needed. That would give us our actual answer. So the area of the triangle that we started off with area is equal to 16.5. And of course, we're talking about units squared. All right. So that's it for this exercise. I'm put a little space there just kind of show it, separate it. But we're going to do a little extra work simply to find the area of the blue triangle. And we're going to go through one more exercise and the assignment. So go and start.